co-chairman to this session. It's my honor and pleasure to welcome Hajič to. Okay, so Jan is a professor at Charles University, where he has been also acting as a director of the Institute for Formal and Applied Linguistics for so many years. He has too many contributions to the field that I can start to spell today. So without further ado, I will just let Jan present his talk on the future of understanding in NLP.
Okay, so good afternoon again. Thanks for the nice introduction. I would like to first, before we talk about what I think natural language understanding is, or how can we approach it in our view, I would like to say a few words also about our institute. Joseph had in the morning very nice introduction to the AI scene, including language and speech. I think we will hear a lot about speech research also from Honza, and I would like to say a few words about natural language processing, which is done at many places, and one of them, it's the Institute of Formal and Applied Linguistics, where I work at the moment. So the Institute was founded 30 years ago after another 30 years of working in various ways and various numbers of people. Currently, we have more than 100 staff, which includes about 25 PhD students and many postdocs and researchers of all kinds. Also a lot of administration because we have various types of projects. We have people in the Institute who are holding various prizes, also international. One of the two biggest in the area are the ACL Lifetime Achievement Award and the Antonio Zampoli Prize on the data side, and we also have other people. And Joseph also have shown that we have one of the ERC grant holders and have submitted some more, so we are hoping to have even more. Now, the Institute is unique in the sense that it was founded by linguists. Now, of course, if you look 60 years ago, that was the way that the field went, that the linguist went out and started thinking about language as a formal system where you can introduce actually rules and eventually even program those rules to help various applications. Of course, as we all know, today the situation is quite different, and it is also reflected in that I would say 90% of the people in our institute are now computer scientists, and of course machine learning people almost all of them. On the other hand, we do keep several groups of linguists who work on the theoretical aspects of language, and we hope that eventually, as one of the founders of the statistical NLP said, who was Fred Jelinek, of course, who said, well, once linguists will help us strike the goal. Now, it doesn't look like these days when we see all the successes about deep learning, but I still think that linguists probably have something to say, not only about machine learning and applications, but even about the language itself, because I think, in fact, for the 50 years, for the last 50 years, the actual basic research into how language works was neglected in the name of applications. Now, we don't have to do that anymore because we have deep learning, but still we would like to know how actually language works in terms of our memory and our understanding, and that's what I would like to talk about in a second. So of course, in the Institute, we have, we have also lots of international cooperation, and that includes France, of course, as we said, with François Yvon. We had a student there. We also have someone who has just become a guest professor of Charles University, Patrice Pognat, who was part of the INALCO Institute and was coming here for 50 years. So there is a lot of cooperation also with other places in France in various European and bilateral projects. Now, of course, our international cooperation is much wider. We are part of many European projects, both, in fact, we started in, well, in fact, one of our first projects in a framework program, still as an associated country in the 90s, was with France. And that was a company in Paris for which we provided morphological analyzer for Czech, and which was funded by the FP5 in that time. Now, one of the bigger things we do in the Institute, and I think about 25 or 30 people are actually engaged in that, is providing data. As we know, now machine learning is all about data. In linguistics, it's no different. François has talked about the need of data for various languages, and we always thought that no one is going to do the Czech data for us. Of course, we didn't know about multilingual models, but anyway, we wanted to start with that. So we were very much engaged in collecting, analyzing, and providing linguistically annotated data for various tasks for Czech. Now, of course, it then expanded to providing the same data for many other languages, which includes actually English and some more. So that's why we also host the language resource infrastructure, which is called LIN.Claria CZ. It's part of the Clarin network, also the Daria network for digital humanities. And it provides many openly accessible data sets, not only for Czech, but for example, in the UD projects, we are providing data for the basic language analysis for more than 160 languages. So this is also a big part of the research supporting all the machine learning methods for natural language processing. So this is one of the tools which is built upon this large database of languages, which is called UDPipe, because it's a pipeline of processing of the basic tools like tokenization, segmentation, lemmatization, morphological analysis, part-of-speech tagging, syntactic analysis. I selected a French sentence for this presentation. So this is the analysis. This is the result of the basic analysis of this first sentence of the AFP website, which says what AFP is supposed to do, and it can also be analyzed syntactically, saying what is the subject, what is the object, what is the predicate in the sentence, or actually in the two sentences, and even draw it graphically. This is sometimes used as a standalone tool for the very basic applications. For example, for web indexing, you only need lemmatization. You don't have to do much of on the linguistic side, but certainly for languages like Czech, French, or even more complicated languages like Finnish or Turkish, you do need to do this type of analysis. Of course, you can now use also deep learning and use embeddings or anything else, but again, people mostly use this at this point. The other task that we work for a very long time is machine translation, and in fact, we started more than 50 years ago, of course, without any machine learning or statistical methods, but in the 90s, we started the statistical type, and recently also deep learning. And I can say that one of my colleagues actually have developed a system which already 2 years ago was checked by colleagues at University of Oxford to actually be significantly better than people in translating news between English and Czech, and surprisingly enough, also between English and French. So we believe this is it was published in Nature Communication. So we believe this was one of the successes. Now, of course, today I believe even DeepL or maybe even Google in some cases can translate. Of course, news translation is one of the easiest tasks in machine translation. We have much more difficult tasks in other domains, especially in domains like medical care or technology or science, and not even talking about poetry or other things, but still I think it's a good achievement. This is something we will pursue further, and exactly in the way that François started looking at multilingual models and multilingual translation models and how they can actually improve translation or even create translation into and from languages for which we do not have data. So here is an example. This is about 2 weeks old example from English where native Czechs, not only me, can say that this is actually a good translation, which would probably be done by people as well. Now, let me now switch. So this was the very basic. Of course, my colleagues at UFAL, both at the PhD level, the postdoc level, and the senior researchers work on many other projects. I can name, for example, a project which was using language models to write a theater play. And actually, it succeeded in that the Švandovo divadlo, for those who know Czech, was actually performing the play, and there were rules how to use the output. So actually, they were only allowed to delete sentences in the output, and otherwise it has to be untouched. Some of the critiques were that it's a little bit Beckettish type of abstract play, or absurd play, but in fact they perform it online because of the COVID times last year. But now they are playing it live on screen, and of course that got a lot of press coverage because it was an interesting project. Now we still think that even for such a project, the machine apparently does not understand what it is saying, right? It is a huge language model which can provide something which is then perceived as a pretty good, even if abstract or absurd play, but of course in the art domain this is normal, right? So it sort of hides the fact that it does not understand what it is saying. So this is a little bit of a bridge to what I want to say now, that we are still trying to come up with some more understanding how we understand language and what people say. Now, when I talk about language, we approach it, of course, from the language side, but as we heard from the question to François, obviously people do understand things in multimodal context. It's very rare that you only listen or read something without anything else. Of course, you do sometimes, but in most cases, you are watching a video, you're seeing what's going on around, you see the nonverbal communication. If you talk to someone, motion, hand motion, face expression, and so on. But we would like to start with the language input as the basic, because after all, we believe that language can in fact express even the non-language part in some ways. Sometimes not exactly, not as quickly, but still, we believe starting with language will give us the biggest head start, so to speak. So what we would like to do is to come up with a representation, because of course if you talk about understanding, you have to say what do you mean by that, right? By understanding we can mean to Turing test, where we will talk to someone, but we know that recently it is relatively easy to sort of fake the success in Turing test. So we have to come up with something more than that, and so we are trying to come up with a representation where actually people would agree if two people look at the representation of the text and they would say, yes, this is what I think I understand under this text, and they would agree with the other person. And of course we can extend it to other things. So we will definitely look at other things, like, of course, logicians understand under knowledge representation something very different. They understand something which comes up with zeros and ones. What we understand under knowledge representation is a graph that sort of represents the relations between entities which we can observe in the real world. For this to succeed, we have to come up with two things. We have to come up with how to represent entities that appear in the real world, which we can touch, we can observe, we can think about, and then the relations between them, typically represented by events. And that's something that we are looking at the most, because, as you know, we have lots of ontologies out there, like Wikidata, Wikipedia, DBase, Freebase, Psych, if I can cite some of the efforts. But we have rarely found a good ontology that would describe events. events or states like be located at, or eat, or go. If you look into Wikipedia, I think you've only 2% of the events that you can come up with are actually described in Wikipedia. Because Wikipedia usually describes instances of events. It describes the Second World War as an event, but it would not describe what eat means. And there are other lexical resources which are very much language-oriented, which do describe it, but none of them seems to have the property of actually be ontology that would really look at the real word and would put together words which express the same thing and distinguish things which should be distinguished. So, in fact, we have a project funded by the Czech Grant Agency where we have to do just this in order to be able then to create the knowledge representation graphs which we believe would actually be able to represent this knowledge. And when we will be able to actually do this experiment, showing these graphs to 2 or more people and asking them, okay, do you think that this is the representation of this document? Right, so this will be not sentence by sentence, how linguistics typically worked in the past. Will be definitely document by document, or even longer things, and they should be represented by these 2 things, by events and entities. And this is a very small example of a very simple sentence. Usually linguistic examples are very artificial, very simple. I will show a more complicated one at the very end. But in this case, we have a simple sentence, John ate pizza, and there is one event of eating. So of course we have to first say what eating is, so we have to refer to what we call the type, event type, eating in general, and of course there will be this very specific event of John eating the pizza, and this one will probably not be grounded in any ontology unless it's very significant eating of pizza by John, but we will still create this instance as well. But the other things are much easier. The events like John and pizza can be easily represented because John is a type of a person, so we have the type entity, and we have John. If we know who the John is, we can use his ID, right? I mean, if he's a scientist, we can use the ORCID ID or his social security number or something to identify the person in the real world. And similarly, the pizza, probably pizza does not have an ID when you buy it, but we can certainly create this one particle pizza. This is a physical entity which could be in principle identified in the real world. And of course, if you are investigating a crime, then you have every little thing identified very well. So in principle, it can be identified. Certainly pizza is also a type of entity which I think would even have a Wikipedia entry. So this is where we are going, and this instance of relation is the important one, because I believe that people think in terms of the real world, even though they think in language, as we know. They think in language terms, but eventually the things which are reflected in the language are the things from the real world. And the link between the represented entity or event and the real world is called grounding, and at least in this case. Of course, we know that the word grounding is used in many other ways as well. But in this case, we would like to have both these events and the entities, and of course both types and instances grounded in some ways where we can agree that this event type is eating, and everybody agrees that in all the texts that we show people that this was about eating, and similarly with entities. Even though with entities, as I said, it is easier because entities already are grounded in many ontologies out there. So this is something that we are trying to do. Here is the promised big example. I won't go through all of it because there is not enough time, but we have tried to, just on a piece of paper, to draw these graphs, and it seems that if we have a good eventive ontology, that we should be able to do this. Again, we have not run, this is all work in progress. We haven't run this experiment between different people saying, coming up with the same representation, but we hope to be able to do this soon. So what remains is to, of course, compare this with other efforts. I mean, we have done it We are part of a US project which is coming up with what they call uniform meaning representation, which is actually, the goals are very similar, even though they are still more on the linguistic level, while we want to go more into the real world, and we will be trying to connect our representation with theirs. We need to do many more languages than we have currently 5, 3 which are already, Czech, English, and German. We are working on Spanish, Korean, and soon we will start with Chinese. And then, of course, we will try to produce data and give it to my colleagues in machine learning so that they can try to replicate the human process of analyzing a document into these graphs. So that's all I wanted to say. There are pointers and some descriptions, and I will be happy to take questions. Thank you.
So I guess we have time for 1 or 2 questions from the audience. Okay, I don't have any on the website either. Oh, there is one, sorry, Joseph, sorry, good.
Thank you very much for the very nice presentation. How do you plan to evaluate this, like say in comparison really on the production of these on these graphs, or do you have in mind some downstream task as well? Thank you.
I mean, we would like to start with the comparison between the language expression and the graphs. And as usual in language annotation task, the only evaluation possible is to measure these, what we call the inter-annotator agreement. So again, if people agree, people who understand their way, so this is our proxy to some other more objective criterion. We cannot watch the brain. Unfortunately, there are no methods today, including, we actually try to look at it, EEG, magnetic resonance. None of them would give us the precision that we could observe something objectively. But if 2 people agree, it is subjective, but we believe that the people, if they understand what's in the text, and if 2 or more people agree, that's some of the criterions. And then we at least have the relation between the outer expression, which is the text or speech, and the representation. Now, we are avoiding at this point to refer to any specific application because that might skew people in thinking about it, in fact, even the annotators. So yes, in the end, of course, this can be used as a side task when learning translation model. It could be used as a side task in anything else, summarization, anything that we would think would need, this type of understanding. And of course, eventually we have to compare it with the standard approach like large language models because they still can win. I don't think that actually translation can be beaten by this, even though translation of some more difficult text than news still makes occasionally, not very often, but the grave errors, like, excluding negation in a sentence, that semantically very important thing, which could turn things completely upside down. So maybe in this task it might help. But our goal is to really simulate understanding and see whether we can reach this agreement, because we believe that's the most important part of it. And then see whether, let's say, psychologists or psycholinguists can confirm some of this with their testing or something else. At the same time, we would like to ask people who actually do work with large language models whether they see some connection, whether it can be ever used as either as an improvement or as some tool, or maybe a tool to understand the language models. One of the applications perhaps could be that if we have this symbolic graph and that was discussed today as well, like trustworthy AI, right? So if you want to show people how the system has actually reasoned about something, and it can be generated into language from these graphs, and then show the graphs, it might be more trustworthy than showing a matrix of numbers and saying, because of this matrix, I have concluded that, you have this disease. So that could be a possible application. But again, this is not really application driven. Okay, thank you.
Okay, thank you. We need to move on, I think. So thank you, Jan, again for this very nice talk.